Hi everyone, welcome back. In this video, I will show you a complete RTL flow using VS Code and Vivado, from writing code and checking syntax in real time, all the way to running simulation and creating a Vivado project from Tcl. This setup supports mixed language design, including VHDL and SystemVerilog, and it is designed to be simple, repeatable, and easy to maintain. Here is what we will cover step by step. First, how to configure real-time syntax checking in VS Code. For example, here instead of C1, you type CL. When you save the code, it shows the error CL is not declared. Then, how to enable Go To Definition using F12 with Ctags. For example, in this example, we use two half adder module and we want to open the half adder module. By pressing F12 keyboard, it jumps to the module and we can see the content of the module. Next, we want to see how to run mixed language simulation VHDL plus SystemVerilog using Makefile. In this case, by run make all, it compiles the file, elaborate files, and finally run the simulation and print the result. And then we want to see how to create a Vivado project from a Tcl script and file list. At the end, you will have a full development loop. Let me quickly show the project structure. Inside source folder, we have SystemVerilog for SystemVerilog RTL file and VHDL for VHDL files. Inside TB folder, we have testbench files. Scripts for automation including Makefile, Tcl, and file list. .vs code for editor settings, tasks, and launch config. The important concept here is that file lists are the source of truth. File list _sv contains SystemVerilog file and location, TB testbench files, and VHDL files. Both Makefile and Tcl use this list, so everything stays consistent. Before using this workflow, make sure these tools are installed: Xilinx Vivado, VS Code, GNU Make, and Universal Ctags. Vivado tools must be in your path, including XVHDL, XVlog, XElab, and XSim. These are included in Vivado installation. In this project, the Makefile checks the toolchain before the compilation starts. Real-time syntax errors in VS Code. Now, let us configure real-time syntax checking. Open the extension tab and search for Verilog-HDL SystemVerilog and install this extension. Then, in the settings.json, configure linting to use Vivado xVlog, verilog.linting.linter xverilog. Also, you can configure this using settings. So open settings, select extension, find Verilog-HDL SystemVerilog extension, Verilog linting, and here select xVlog. If you want to use another linter tool like iVerilog or Verilator, you can choose it here. With this setup, syntax issue appears directly inside VS Code while editing. So for example, here we forget to write semicolon and it prints errors. This is great because you catch mistakes immediately instead of waiting until simulation. Enable F12 Go To Definition with Ctags. We want to enable fast symbol navigation. For this purpose, open the extensions and search for Ctags Companion and install this extension. Also, you must install Universal Ctags. Scroll down to the end of the file and follow this instruction based on the operating system to install universal C tags. Then generate tags with this command. In this project, this command is already configured as a VS Code task called generate RTL C tags. You can find it in the settings.json here, Ctags Companion command and this command. To run this command, open Run and Debug tab and select Generate RTL tags. Click the green button. This will run the command and generate a C tags. You can see it here. Now try F12 on modules, entities or symbols. You can navigate across SystemVerilog and VHDL. For example, we open the test bench and we want to open the full adder module here. We press F12 and it jumps to the module. Now we want to open half adder. We select it, press F12 and it jumps to the module and we can read the content. Simulation flow with Makefile. Now the core part, simulation. Switch to the scripts folder. Then run the full flow using make all. Let's look at the Makefile. This flow does check env to validate toolchain, compile VHDL from file list vhdl.f with x VHDL, compile SystemVerilog from file list _sv.f with x Verilog, and compile testbench from file list _tb.f with x Verilog. Then elaborate with xelab and simulate with xsim. Also, Makefile extracts testbench top from file list _tb.f and use it automatically for xelab and xsim. If all tests pass, you should see success output in the terminal. Open Waveform. To open Waveform after simulation, run make wave. This launches xsim GUI with the waveform configuration file so you can inspect signal visually. Create Vivado project from Tcl. Now let us create the Vivado GUI project. First open the Vivado. In Vivado, go to Tools, click Run Tcl script. Go to script folder and select create project.tcl. Press OK. This script read file list SystemVerilog, VHDL and testbench. Add files into the correct file sets, set source top and simulation top, and update compile order. When done, in the Tcl console you should see project successfully. Let's check the project console. Here you can see the project created successfully. This means your GUI project is built from the same file list used in command line flow, which avoid mismatches. Thank you for watching and see you in the next one.